Yeah, good morning all. Now next problem is the coefficient of reflection of voltage for a short circuited line is. Okay, already we know that the coefficient of reflection, that is V1 by V is equals to ZL minus ZC by ZL plus ZC. Okay, short circuited line means load impedance value is 0, right? Okay, see here, right? V1 by V, that is reflection coefficient, is equals to ZL minus ZC by ZL plus ZC. Okay, when secondary is short circuited means load impedance is 0, right? That means ZL value, substitute ZL value as 0, then I will get a value as 0 minus ZC by 0 plus ZC. You will get minus ZC by ZC. You will get the answer is minus 1 is the answer. Okay, that is B is correct. Next, the insulation resistance of a cable of length 10 km is 1 mega ohm. Okay, its resistance for 50 kilo ohm length will be. Already we know that insulation resistance is inversely proportional to length, right? Now just observe clearly. Length is first starting stage 10 kilometers. After that 50 kilometers. That means 10 into 5 you will get 50 kilometers, right? That means length is increased by 5 times. That means the insulation resistance is reduced by 5 times, that is 1 mega ohm divided by 5, then you will get the answer is 0.2 mega ohm is correct. That means what is the first answer? Third option is correct. Next, the capacitance of a 3 core cable between any two conductors with sheath earth is 2 microfarad. Then the capacitance per phase will be, here the formula for capacitance per phase is 2 into Cc plus 2 plus Cs. C suffix C indicates capacitance between two cores. C suffix S means capacitance from one phase to sheath. Okay, now see here. Yes, now 109th one is capacitance per phase is 2 into Cc plus Cs, right? When sheath is earthed, Cs value is 0. Then capacitance per phase value will be 2 into Cc value is 2 microfarad is given. Then the answer is 4 microfarad is correct. Next, if delta is the loss angle of the cable, its power factor is, okay, in case of underground cables, power factor formula, remember this one, very important, that is sin delta, not cos delta. Okay, next, 111. Next question, the effect of bonding the cable is, okay, it increases the effective resistance and reduce the inductance. That means second option is correct. Next, in order to eliminate sheath loss, a successful method to transport the cable along with cross bonding. That means answer is first one. Next, the sending end voltage of a feeder with reactance 0.2 per unit is 1.2 per unit. Okay, if the reactive power supplied at the receiving end of the feeder is 0.3 per unit. Okay, the approximate drop of voltage in the feeder. Okay, that means what is given here? Sending end voltage is given, reactive power is also given, right? What is the sending end voltage? Sending end voltage is given as 1.3 with a 1.2 with a reactance of 0.2 per unit. Okay, and the reactive power supplied by the receiving end, okay, the reactive power supplied by the receiving end of your line is 0.3. okay, then Vs minus Vr, we will get a voltage drop in the feeder. Vs is nothing but sending end voltage, Vr is nothing but receiving end voltage, right? Sending end voltage is given as 1.2 per unit, right? Then the formula for receiving end voltage in voltage improvement, okay, the receiving end voltage formula will be, okay, magnitude of Vs minus X is nothing but inductive reactance divided by magnitude of Vs into Qs. Now see here, already we know Vs value, X value and Qs value, right? Then receiving end voltage is equals to 1.3 minus 0.2 divided by 1.3 into QS value is 0.3, right? That is 1.3 minus 0.2 divided by 1.3 value will be 1 by 6, right? Okay, into 0.3. Okay, that is 0.3 divided by 6 is nothing but 0.05. That is 1.3 minus 0.05 is nothing but 1.25, right? Then Vs minus Vr is nothing but 1.3 minus 1.25, that is 0.05 per unit is the answer. Now from the given options, third answer is 0.05 per unit, right? Then third answer is correct. Next question. If a synchronous machine is overexcited, it takes a lagging VARs from the supply. When it is operated as synchronous motor, not correct. Synchronous generator, not correct. That means none of the above is correct here. Next, if a synchronous motor is underexcited, it takes lagging VARs from the system when it is operated as. Okay, if a synchronous motor is underexcited, it takes lagging VARs. That means if it is a synchronous motor as well as synchronous generator, it will takes lagging VARs. That means first option is not correct. First option, suppose if only one is synchronous motor is present, that is correct. Only synchronous generator is correct, that means second option is also correct. But third option is given synchronous motor as well as synchronous generator, right? That means 115. Question will answer is C is correct answer. Next, a synchronous machine has higher capacity for higher capacity for leading power factors. Next, a machine designed to operate at full load physically heavier and is costlier if the operating power factor is lagging. Next, for the same voltage boost, the reactive power capacity is more. For same voltage boost, the reactive power capacity is more for a shunt capacitor. Next, synchronous phase modifier as compared to a synchronous motor used for mechanical load has. First option, large shaft and higher speed. Second option, smaller shaft and higher speed. Third option, larger shaft and smaller speed. Fourth option, smaller shaft and smaller speed. Now see here, what is given? Synchronous phase modifier as compared to synchronous motor. Okay, it has smaller shaft and higher speed. That means smaller shaft means B. Yeah, B is correct. Next, if IA1 is the positive sequence current of an alternator and Z1, Z2 and Z0 are the sequence impedances of the alternator, the drop produced by the current IA1 will be, it is having only positive reactance, that is the voltage drop across that positive reactance will be IA1 into Z1. That means first answer is correct. Next, for the system shown in diagram below, a line to ground fault on the line side of the transformer. Okay, line side of the transformer is equivalent to 2. Now see here, at transformer secondary side, if fault is occurs, right, that means it acts as a ground fault. Why? Because in transformer secondary is connected to star grounding, right? Grounding means it provides a path. For primary side and generator side, primary winding of a transformer is connected to delta, right? Delta is having closed path, but it doesn't have any neutral, right? Hence it acts as line itself acts as a one line. This is also act as a one line. That means that fault can be treated as line to line fault on the generator side of the transformer. Suppose if it's secondary side, that is line to ground fault. That means from the given options, line to line fault, where is given first one is line to ground, that is not correct. Second one is line to line fault on the generator side of the transformer, that is correct. Third option, double line to ground, already ground, again ground is included, no ground possible for primary side of the transformer, right? That means second option is correct. Next, the positive sequence component of voltage at the point of fault is 0. when it is, okay, when it is three phase fault, then only it is absent. Next, tick out the correct statement. The negative and zero sequence voltages are maximum at the fault point and decreases towards the neutral, right? That is 123rd question. First option is correct. Next, for complete protection of a three-phase line, okay, that means three-phase line means we need to protect lines as well as line to ground faults, right? That means for line to ground fault, one relay. That means for ground faults, one relay should be present. For phase fault, between two lines, one phase to phase relay, right? Between three phases, one phase to phase relay, right? That means two phase relays and one earth relay is required, right? Two phase relays and one earth fault relay are required for the protection. See the solution here, right? Maximum possible faults, line to ground and line to ground. Okay, for this grounded faults we need to require one earth fault relay, right? For two lines and for three lines, two different relays, two phase relays are required. That means total required relays will be two phase relays and one earth fault relay is required. Next, last question. The phase comparators in case of static relays and electromechanical relays normally are, that is cosine and sine comparators, that is those are the static relays. Okay, thank you all. Remaining we will see in next class. Okay.